In this video, I have two functions. One is f of x is equal to negative 3x plus 2. The other one is g of x is equal to 5x minus 7. I would need to find f plus g and f minus g, f times g, and f divided by g. I am going to find these functions, new functions, one by one. So let's consider the first case, number 1. I would need to find f plus g of x, which by definition we define it as f of x plus g of x. That is gonna be, my f of x is negative 3x, f of x is negative 3x plus 2, plus my g of x is 5x minus 7, 5x minus 7. Here I just have to combine the like terms. Negative 3x plus 5x is 2x, and then 2 minus 7 is negative 5. So my f plus g of x, f plus g of x is 2x minus 5. Now we need to pay special attention to something here, the domain of the new function. The given functions f of x and g of x, these are defined for all real numbers. As you can see, these are technically a straight line, which is also polynomial of first degree. Now these functions are defined for all the numbers on the number line, both f of x and g of x. However, the new function that we found, f plus g of x, we need to find the domain of this new function as well, which may or may not be the same as the domain of the previous functions. In our particular example, it turns out that the domain of this new function, f plus g of x, is the same as the domain of the original functions, which is the real number line. So domain for this one is going to be from negative infinity to positive infinity. So the entire number line, because 2x minus 5, by the way, is a straight line or first degree polynomials. Remember, the polynomials, they have domain the entire number line. Basically, any real number would do it. Now let's do f minus g of x, which is here. By definition, it's f of x minus g of x. My f of x is negative 3x plus 2. My g of x is 5x minus 7. The key thing here to pay attention to is that this negative sign is in front of the parenthesis, or the second function must be within the parenthesis, and then you put the negative in front. If you just write it negative 5x minus 7 without the parenthesis, then that would be a mistake. So we need to distribute this negative. So we need to keep that in mind. So the first thing is negative 3x plus 2. Then negative 1 times 5x is negative 5x. And negative 1 times negative 7 is positive 7. Now if I combine the like terms, negative 3x minus 5x is negative 8x. And then 2 plus 7 is 9. So this is my f minus g of x. Also, as it turns out, this is also a straight line. So meaning the domain of this new function, which is constructed by taking the difference of f and g, is still the same as the domain of the original functions from negative infinity to positive infinity, which is the entire number line. Now we do the product, f times g of x. We define it to be f of x times g of x. This is my f of x and this is my g of x. Now I need to simplify it. So I would need to use the FOIL. So basically I will use the distributive property. So distribute negative 3x times 5 is negative 15x squared. Negative 3x times negative 7 is 21x positive. Then 2 times 5x is 10x. 2 times negative 7 is negative 14. Now if I combine the like terms, I get negative 15x squared. 21x plus 10x is 31x, then minus 14. Now this new function that we found, by the way, right here, this is also a polynomial of second degree. So this is gonna be having a domain the same as the domain of the original functions, which is basically from negative infinity to positive infinity. Remember, polynomials, their domain is the entire number line. So this is a polynomial of order 2, 15x, negative 15x squared, so the highest power of x is 2, is the polynomial of order 2 or quadratic polynomial. So it has a domain negative infinity to positive infinity. Now we are going to do the division or quotient f over g of x. By definition, or we define it as f of x divided by g of x. My f of x is negative 3x over 3x plus 2, and my g of x is 5x minus 7. Now this one you have to pay special attention to, because there is division involved here. You want to make sure that you do not divide by 0. That means you want to make sure that 5x minus 7, that doesn't become 0. So we need to find out what value of x is going to make 5x minus 7 0. If you solve for x, you will see that it's going to be 7 over 5. So this value, if you plug it into this equation for x, is going to give you 0 in the denominator, meaning you will be dividing by 0. But that is unacceptable. So this function has domain restriction, unlike the first three. The first three, addition, subtraction, and multiplication, we had the same domain for the new function as we had for the original functions, f and g. However, in this case, that will not be the case. What it is, for the quotient, we have to exclude the point 7 over 5. So we would like to exclude this point. So we want all the numbers on the number line, okay? We want all the numbers on the number line except for the number 7 over 5. Now let me go ahead and summarize what I have talked about in this video. Basically, we have taken two functions, f and g, and then we created new functions out of these two functions by applying the usual addition, subtraction, multiplication, and division. And we needed to be careful about the new domain of the new function that we get. In our particular example, it's not always true. In our particular example, the new domain is the same as the original domains for 1, 2, and 3 for addition, subtraction, and multiplication. However, for division, that is not the case. For division, our domain is different. Our domain is going to be, in this particular case, from negative infinity to 7 over 5. You do not include that point. Union, open parenthesis, 7 over 5 to positive infinity. And that's how you'd find the domain of the new function, particularly when you are doing division of one function by another. You want to make sure that the denominator does not become 0 for any value of x. For that value of x, the function will be undefined. I hope that this discussion was helpful. Thank you very much.